Good day, everyone. We are working on this question from January. We are working on this question from January 2021, paper 2, CSEC Mathematics. Number 3, the diagram below shows two pentagons, P and Q, drawn on a grid made of squares. So a pentagon is a 5-sided polygon. So we are asked to select the correct word from the following list to complete the statement below. Pentagon P is something to pentagon Q. So when we observe them, the word opposite doesn't work here. The word reflected doesn't work here. Okay, the word translated doesn't work here because the orientation of the shape has changed. All right, so these words did not work. All right, and therefore the only word we end up with is congruent. Okay, so we have congruent as the word that we chose. The reason why is because pentagon P and Q are identical in every respect. All right. All right. Also, we could say that the orientation of Q is different from P, which rules out translation. So it cannot be a translation because the orientation of pentagon Q is different from that of pentagon P. Okay, all right, so let's go ahead now. We have pentagon again. We are given some angles and there are some lines here which indicate certain lines are parallel to each other. We are asked to find the angle WXY. So this is the one we want to find, the angle in the middle. All right, we could extend this a little bit. We could also extend this line a little bit. All right, so when we do that, we see that, yes, we see that these two angles are equal and that they are corresponding angles. Right, so angle Y and this angle outside here, this exterior angle, are equal. And that means that in order to work out angle WXY, we need to just subtract 114 from 180. All right, so we get 66 degrees as this angle. All right. Since a straight angle has 180 degrees on it. All right, so the working was 180 subtract 114 equals 66. All right, angle ZVW, angle ZVW, they want us to work out this angle here. All right, so we need to find angle VWX, which is up here. So we can extend these sides a little bit. All right, and we will see that, all right, this angle appears 114 degrees, and with vertically opposite angles, the angle at W, VWX will also be 114 degrees. Okay, so we know that a pentagon has 180 by n minus 2 degrees on the inside. where n is the number of sides, right? So this is 180 by 3 subtract 2. Sorry, not 3 by 5 subtract 2, since n is the number of sides. All right, so we have 180 multiplied by 3, which is 540 degrees. So a pentagon has 540 degrees on the inside. Let's find the missing angle. So when you add 98 to 114 to 114 to 66. All right, so 98 plus 114 plus 114 plus 66 plus the angle ZVW is equal to 540 degrees. So we can now work out angle ZVW. All right, you just add up the angles on the left of the equal sign. We have 98 plus 114 plus 114 plus 66 at 422. So we just say ZVW is 540, take away 422, which is 118 degrees. Okay, so the answer is 180 degrees, 118 degrees, sorry. Okay. We're doing this question now. There's an enlargement by scale factor 2 about the center 6.6. So the image is going to be twice as big as the object. The image is going to be twice as big as the object. Okay, so let's get ready for that. So we draw lines passing through each point. Okay. So we have one line here. Then we have another line here. All right, so the distance from the center of enlargement to the point of the image is twice as much as the distance of the center of enlargement to the point on the object, because it's an enlargement using a scale factor of 2. Okay, so we just keep drawing lines that connect the center of enlargement to each point, and we extend it twice as long. All right, so we keep doing that. All right. All right, and so it's time for us to draw, connect these 5 points. All right. Okay, so we connect our points. All right, so the red capital A is our image after an enlargement by a scale factor of 2. Note that the length of the line from the center of enlargement to one point on the image is twice as long as the length of the line from the center of enlargement to the point on the object. Okay, so we drew our lines to 5 points, 1, 2, 3, 4, 5. Okay, so they want us to do a translation now of the letter A using the vector -3. and 2, right? So -3 means we are moving 3 places to the left, and +2 means we are moving 2 places upward. So we are going 3 units to the left, 2 places upward, right? So that's what we're gonna do. So let's go 3 places to the left. So from each point you go 1, 2, 3, and 1, 2. So we have a point up here. Then we are going 1, 2, 3, and 1, 2. We have another point here. Then we have 1, 2, 3, and 1, 2. We have another point here. And we go in here now. All right. So, all right. So 1, 2, 3, 1, 2. So we have a point here. And then 1, 2, 3, 1, 2. We have a point here. Okay, so we then connect these dots with lines. All right, so we have something like this. All right. We have this. All right, so that is what the translated object looks like. So we have our object in black and the image is in red. Okay, so that's the end of number 3 for January 2021 CSEC Mathematics. Thanks for watching and do have a good day. And one more thing, let's just do one more thing before we close. Let us just identify which answer is for which question. So this is number 3, part 1. This is our enlargement. So I'll write a little part 1 here. Part 2 answer the translation of the letter using the vector. I will write that here. This is part 2's answer, right? So part 1 and part 2, we identify clearly which one is our answer for which question. Thanks for watching. Have a great day.